November 1942. An American soldier crouches behind a stone wall in Tunisia, watching a German Panzer IV advance through the olive grove 200 meters ahead. The tank's 75mm gun traverses slowly, searching for targets. The soldier has no anti-tank gun. His unit has no artillery support. What he has is a 5-foot metal tube resting on his shoulder, loaded with a rocket-propelled grenade weighing 3.5 pounds. He aims at the tank's hull, leading slightly for movement. He squeezes the trigger. The rocket ignites with a sharp crack and a plume of white smoke. It travels at 83 meters per second, crossing the distance in just over 2 seconds. The shaped charge warhead strikes the Panzer's side armor and detonates, focusing explosive energy into a jet of molten metal that punches through 4 inches of steel plate. The tank stops moving. Smoke pours from the hatches. The crew bails out. The soldier drops the launcher and runs. He does not retrieve it. The weapon cost $18 to manufacture and was designed to be discarded after perhaps 10 shots. It was called the bazooka, and within 6 months of its first combat use, it had fundamentally altered the tactical relationship between infantry and armor. The United States Army entered World War II with an anti-tank problem that was doctrinal and technological. American infantry doctrine assumed anti-tank defense would be provided by towed artillery and tank destroyers, specialized units positioned behind the front line. Infantry squads had no organic anti-tank capability beyond rifle grenades, which were ineffective against any armored vehicle heavier than a light reconnaissance tank. The standard anti-tank rifle grenade could penetrate approximately 40 millimeters of armor under ideal conditions. German medium tanks carried 50 to 80 millimeters of frontal armor. Japanese tanks were lighter, but still adequately protected against rifle-caliber weapons. Infantry encountering enemy armor had 3 options: withdraw, call for support that might not arrive in time, or attempt a close assault with satchel charges or Molotov cocktails. All 3 options resulted in high casualties and loss of ground. What infantry needed was a weapon that individual soldiers could carry, that could penetrate medium tank armor at combat ranges, that required minimal training to operate effectively, and that could be produced quickly in massive quantities using available industrial capacity. The solution emerged from research conducted at the Aberdeen Proving Ground in Maryland beginning in 1941. Army Ordnance had been experimenting with rocket propulsion for several years, seeking alternatives to conventional recoilless rifles. Recoilless weapons worked by venting propellant gases rearward to counteract recoil, but they were complex, heavy, and expensive. Rockets offered a simpler approach. A solid-fuel rocket motor could propel a warhead without requiring the launcher to absorb recoil forces, allowing the launcher itself to be nothing more than a simple tube. The challenge was developing a rocket that was stable in flight, accurate enough for combat ranges, and powerful enough to defeat tank armor. The shaped charge warhead solved the penetration problem. Shaped charges used the Monroe effect, discovered decades earlier, where explosive detonation focused through a conical metal liner creates a high-velocity jet capable of penetrating armor much thicker than conventional explosives could breach. The M6 rocket, standardized in 1942, combined a 1.5 kilogram shaped charge warhead with a solid rocket motor. Total weight was 1.54 kilograms. Length was 540 millimeters. The launcher, designated M1, was a seamless steel tube 1.37 meters long, weighing 5.9 kilograms. It had no moving parts except the trigger mechanism and basic iron sights. 2 soldiers operated it: a gunner who aimed and fired, and a loader who inserted rockets from the rear and connected the electrical firing circuit. The firing sequence was mechanically simple. The loader inserted the rocket into the rear of the tube, ensuring the contact springs engaged the rocket motor's electrical terminals. The gunner placed the launcher on his shoulder, aimed using the iron sights, and pressed the trigger. This completed an electrical circuit powered by a battery in the pistol grip. Current flowed to the rocket motor igniter, which lit the propellant. The rocket accelerated down the tube and exited at approximately 83 meters per second. Exhaust vented rearward in a cone extending about 15 meters behind the launcher, creating a distinctive smoke signature and making backblast dangerous to anyone standing too close. The rocket was stabilized in flight by 3 fins that deployed after leaving the tube. The maximum effective range was approximately 140 meters against moving targets and 275 meters against stationary targets. Beyond this, accuracy degraded rapidly due to the rocket's relatively low velocity and susceptibility to crosswinds. The shaped charge warhead could penetrate approximately 100 millimeters of armor plate at optimal impact angle, sufficient to defeat the side and rear armor of most German and Japanese tanks encountered in 1942 and 1943. Operational deployment began in November 1942 during Operation Torch, the Allied invasion of North Africa. Initial combat use revealed both the weapon's potential and its limitations. Soldiers found the bazooka remarkably easy to operate. Training time was measured in hours rather than weeks. The psychological impact of giving infantry a credible anti-tank weapon was substantial. Units no longer felt helpless when encountering armor. The weapon's effectiveness against bunkers and fortified positions was an unexpected benefit. The shaped charge warhead could blast through concrete and earthworks, making the bazooka useful for reducing fixed defenses as well as engaging vehicles. Combat reports from Tunisia documented bazookas destroying or disabling German tanks at ranges from 50 to 200 meters. Hit probability at 100 meters was approximately 50% with trained crews. Closer ranges improved accuracy, but exposed the crew to enemy infantry supporting the tank. The limitations became apparent quickly. The electrical firing system was vulnerable to moisture. Damp conditions frequently caused misfires, forcing crews to discard malfunctioning rockets. The rocket's low velocity meant a significant time of flight, requiring shooters to lead moving targets by several meters at typical engagement ranges. The backblast signature immediately revealed the shooter's position, drawing return fire. German tank crews learned to watch for the distinctive smoke plume and respond with machine gun fire before the bazooka crew could reload. Reloading took approximately 15 seconds with a practiced loader, but under fire, this often proved too slow for a second shot. The shaped charge warhead's effectiveness was highly dependent on impact angle. Strikes against sloped armor at oblique angles often failed to penetrate. Frontal shots against German medium and heavy tanks were unreliable unless fired at very close range, where vulnerable areas could be targeted precisely. Comparison with equivalent weapons from other nations illustrates the bazooka's distinctive approach. The British Piat, introduced in 1943, used a spring-powered spigot mortar to launch a shaped charge bomb. It had no backblast signature, but was heavier, more complex, and required significant physical strength to cock. The effective range was shorter, approximately 100 meters. The German Panzerschreck, introduced in 1943, was a direct copy of captured bazookas, but scaled up to 88 millimeters diameter with a larger warhead and protective shield for the gunner. It was more powerful, but also heavier and more expensive. The Soviet RPG-43 was a hand-thrown shaped charge grenade, simpler but requiring the thrower to approach within 20 meters of the target. The bazooka occupied a middle ground, more capable than hand-thrown weapons, simpler and lighter than recoilless rifles, adequate against most armor at practical infantry engagement ranges. Production scaled rapidly through 1943. By late 1944, approximately 460,000 bazookas had been manufactured. Cost per unit was between $18 and $25 depending on variant, making them genuinely expendable by military standards. The M9 improved model, introduced in 1943, addressed the moisture sensitivity with better electrical insulation and added a forward grip for the gunner. Weight increased to 6.5 kilograms, but handling improved significantly. The two-piece collapsible design allowed easier transport.
Later variants included the M9A1 with improved optical sight and the M18 with aluminum construction for airborne operations. None of these modifications addressed the fundamental limitations of low rocket velocity and backblast signature, which remained inherent to the design approach. The tactical impact was measured not in tanks destroyed, but in infantry confidence restored. Precise kill statistics are unreliable, but estimates suggest bazookas accounted for several hundred armored vehicle kills in the European theater and comparable numbers in the Pacific. More importantly, the weapon's presence forced enemy armor to operate more cautiously, to maintain greater distance from infantry positions, and to coordinate more closely with supporting infantry to suppress bazooka teams. This changed the tempo and geometry of armored assaults. Tanks that might previously have advanced aggressively into infantry positions now held back or sought covered approaches. The psychological effect multiplied the physical effect. Every infantryman with a bazooka was a potential tank killer. Every tank commander had to assume bazookas were present. The bazooka remained in U.S. service through the Korean War, where it proved less effective against Soviet T-34 tanks with their thicker frontal armor. The M20 Super Bazooka, introduced in 1950 with an 89mm warhead, addressed this deficiency but at the cost of increased weight and complexity. In Vietnam, the M72 Law, a disposable single-shot weapon, had largely replaced the bazooka for most infantry anti-armor roles. The original bazooka design was retired from U.S. inventory by the late 1950s, though various armies continued using captured or licensed versions for decades. Total production across all variants exceeded 500,000 units. The weapon that cost less than $20 to manufacture had demonstrated that disposable military equipment could be strategically valuable if deployed in sufficient quantities to offset individual item limitations. The American soldier in Tunisia who fired that first combat rocket and discarded the launcher never knew the weapon's serial number, never maintained it, never considered it anything but a temporary tool for an immediate problem. That attitude was precisely what the designers intended.